doing some questions that are similar and will help you study for your upcoming quiz 6. I do recommend that whenever I do say that it's a good idea for you to pause and try this yourself, maybe on a scrap piece of paper, that you do that. Remember that your quizzes are open note. So if you do take these notes on a separate sheet of paper and bring them in on the day of your quiz or keep them in your binder, you are allowed to use those on your quiz. So for this first question, we are given 4 different number lines, and I would like for you to write the inequality that matches each number line. So for this first number line, A, we have there's 2 different features that you want to look at when you're looking at the shading of the number line. So you have your regular number line, and we see that this number line has a closed circle at 18. And then everything to the left of 18 is being shaded. So if we were going to compare some number x and 18, we know that the number x is going to be less than 18 or equal to 18 because this dot is colored in. If it was an open dot, then that would mean that 18 is not included. So I would like for you to pause the video now and try B, C, and D on your own. All right, so now let's take a look to see how you did on B, C, and D. So again, this number line B has a closed circle at 18, and it is being shaded to the right. Anything to the right is greater than, so if we were to compare some number x and 18, we are talking about some number that is greater than or equal to 18. For number line C, we have our closed dot at 22. So comparing some number x and 22, everything to the left is being shaded. So this number has to be less than or equal to 22. And in fact, all of these have closed dots at our number. So all of these are going to be either greater than or equal to or less than or equal to. This is to the right. So this is going to be greater than or equal to 22. Okay. Next question. So this says solve for x, and this is an equation. So whenever we are looking to solve for a number, we want to do our order of operations in reverse. So if we remember our order of operations, PEMDAS, whenever we are evaluating an expression, so let's say that we had an expression that looked like similar to what we have, right? And we wanted to know what that equaled. If we had the question mark on the other side of the equal sign, then, or like we wanted to know what the whole expression equaled, then we would do PEMDAS regularly. In this case, we don't have that. We still need to remember PEMDAS. But in this case, we are given 4 times some number plus 8 equals 80. Okay, so now our question mark is in our expression. So in those instances, you want to do PEMDAS in reverse. So you want to undo your addition and subtraction first. Then you want to undo your multiplication and division second. So here, if we take a look at this example, always remembering that we have to keep our equations balanced. So again, we want to undo our addition and subtraction first when we are solving for a variable, when our question mark is in our problem, okay? So in order to undo this addition here, we have to create our additive identity, which is 0. So we want to subtract 8 from both sides so that way we get a giant 0 here. So we still have this 4x on the left-hand side. We bring down our equal sign, and on our right-hand side, we have 80 minus 8, which is 72. Then now we have 4 times some question mark, right, is equal to 72. We need to create our multiplicative inverse, which is our multiplicative identity. So we get our giant 1 here. 1 times x is just x on our left-hand side. And 72 divided by 4, I forget. I think, is it 12? I don't think so. 72 divided by 4 is 18. So here we have x is equal to 18. So we undid our addition and then we undid our multiplication. We undid our addition by subtracting to create our 0. Then we undid our multiplication by dividing to create our 1. That will be the same process whenever you see something that looks like this, which a lot of your two-step equations will look like. Next problem, which value of x is a solution of any of the equation? Ooh, did I delete the equation? I think I deleted the equation. Hold on. All right, boom. So here's our equation. Which value of x is a solution of the equation? And we have 20 divided by x plus 11 is equal to 20 plus 16 divided by 2. I want to first start by understanding what it means for something to be a solution. So remembering that every line is really made up of infinitely many points, right? There's really a bunch of points that exist, and they are so many that they just look like a line when you put them all together. Each of these points is a solution to the line. So we're really looking for a point that makes this equation true. The easiest way to approach this problem is to look at all of your possible answer options and work backwards. So I'm going to start off by trying x equal to 2. And I want to see if I plug in 2 into this equation for x, will I get a true statement? So I'm going to rewrite my equation, but everywhere where I see an x, I'm going to put a 2 to see if 2 would make it true. So we would have 20 divided by 2 plus 11 is equal to 2 plus 16 divided by 2. So on my left-hand side, I want to, again, so now we're doing our order of operations in from left to right. So we want to do our division first and then evaluate our addition. So 20 divided by 2 is 10 plus 11. On our right hand side, we have 2 plus 16, which is 18, divided by 2. So 10 plus 11 is 21. And our right hand side, we have 18 divided by 2, which is 9. Well, 21 is not equal to 9, so that is not a solution. So 2 is not a solution because when we plugged it into the equation, it did not give us a true statement. So let's try x is equal to 5. So again, everywhere I see an x, I'm just going to put a 5 to see if 5 is a solution. So 20 divided by 5 plus 11 is equal to 5 plus 16 divided by 2. 20 divided by 5 is 4 plus 11. 5 plus 16 is 21 divided by 2. Is that right? 16, yep. And then 4 plus 11 is 15 on our left-hand side. 21 divided by 2 is, I think, 10.5? 10.5. So we have 15 is equal to 10.5. Again, not true. So 5 is not a solution to this expression. It is not a value that makes this equation true. Let's try. I think I'm going to have to erase some stuff. I'm going to erase all my red. Oops. No, I don't want to erase all of that. Nope. I'll go back here. Okay, so let's try x is equal to 10 now. So let's plug in 10. So we have 20 divided by 10 plus 11 is equal to 10 plus 16 divided by 2. 20 divided by 10 is 2 plus 11. On our right hand side, we have 10 plus 16. That's 26 divided by 2. On our left hand, 2 plus 11 is 13 is equal to 26 divided by 2 is 13. Oh, well, look, we end up with a true statement. So that means that x equals 10 is the solution. And you could try D as well, just to double check that C is your only true answer. But the answer here would be x equals 10 is the only value of x that would make our original equation true. And lastly, describe what was done to get from the first step to the second step. If this is step number 1 and this is step number 2. So take a second, pause the video and look to see if you can figure out what is different between step 1 and step 2. And then looking over here on the right at our properties that we've gone over before, which one of those do you think was used? I'll give you a second starting now. All right. So you might have noticed that the 3x and the 7 were switched going from step 1 to step 2 here. In step 1, we have plus 7 first, and then we have plus 7 second. And in step 1, we have minus 3x first, and in step 2, we have minus 3x first. So we kind of swapped those. So looking at your properties again, which one do you think was used in order to move things back and forth? So you might have noticed that, yep, your commutative property is what you want to think of. Again, the word commute, that core word commute, meaning to go back and forth, like you commute back and forth to work, you commute back and forth to school. Okay, so moving things back and forth. So moving things from first place to second place to first place, that is your commutative property. Your identity property is anything that is either added or multiplied that does not change the identity or the value of that item. So like adding 0 doesn't change the identity, it preserves the identity. Multiplying by 1 also preserves the identity of any number. And then we also have our distributive property where, as your example, you have to distribute this 2 to everything inside parentheses using multiplication. So 2 times x would give us 2x, plus 2 times 4 would give us 8. So distributing using multiplication.